Welcome to this video all about direct and inverse proportion. You can find the PDF with questions, clues and full solutions on mathsupgrade.co.uk. The first set of questions here are all non-calculated questions. The first one's worth 3 marks. It asks us to find the value of y when x equals 64. We're told that y equals 1 1/6 when x equals 8, and we're told that y is directly proportional to the cube root of x. So we're going to use this information here, the top line here, to represent this with an equation. We're then going to substitute these values to find the value of the constant, and then we're going to substitute that constant to find the value of y given that x equals 64. So these are the steps we're going to take here. So first step, representing this with an equation. Since y is directly proportional to the cube root of x, we can write this. This symbol means directly proportional to. Then we can replace this with an equation. So we say y equals a constant of proportionality here, which I've represented with k, times the cube root of x. This constant doesn't change regardless of the values of x and y. It never changes. So we need to find the value of this. To find the value of this, we're going to substitute these known values in and then find this k. So first of all, let's rearrange this equation to make k the subject. So let's divide by the cube root of x on both sides, since that's the inverse of multiplying by the cube root of x. So that gives us y over the cube root of x equals k. If I substitute in y equals 1 1/6 and x equals 8, I'll get this here. Now to work this out, what I'm going to do, I'm going to first of all convert this into an improper fraction, which is 7 over 6. And I'm also going to work out the cube root of 8, which is 2. So I'm going to do 7/6 divided by 2. 7/6 divided by 2 is 7/12. K is 7/12 without a calculator. Now I'm going to substitute this back in to this equation here with my constant as 7/12. So y equals 7/12 times the cube root of 64. The cube root of 64 is 4, so I need to do 7/12 times 4, which is 28/12, which when I cancel this is 7/3. And I'm going to rewrite that as a mixed number, since that's how the values here were written as mixed numbers. So the answer would be 2 1/3, and that would be 3 marks for that question. Question 2 is different to question 1 since y is actually now inversely proportional to x. That means as y increases, x will decrease. So I'm going to represent this with an equation. I'm going to substitute these values to find the value of k. Then I'm going to substitute k back into my original equation and substitute this x equals 6 in to find the value of y. So here's my steps here. This time I've written y is proportional to 1 over x, since it's inversely proportional. So my constant is now being divided by x. I'm going to rearrange this to make the constant the subject of the equation, so k equals xy. I'm just going to now substitute these values in to find the value of k. So 1.5 times 36. So I can find 1 times 36, which is 36, 2 times 36, which is 72. So I need to find halfway between 36 and 72, which is 54. So k equals 54 without a calculator. Now I'm going to substitute this into this equation here. So y equals 54 divided by x, and x equals 6, so 54 divided by 6, which is 9. So y equals 9. Let's just check if this makes sense. So when x is a small value, y is a big value. When x is now a bigger value, y should be smaller than it was before, and it is. So that makes sense. So that is 3 marks for that question. In question 3, I've given a table which has got a set of values for x and y. So the table's fully completed. For the first 2 marks, I'm told that y is inversely proportional to the square of x. So I have to find an equation for y in terms of x. So to do this, I'm just going to form an equation. Then I'm going to substitute any set of values from this table to find the values of the constant. So this is what I'm going to do here. So I know that y is inversely proportional to the square of x. So y is proportional to 1 over x squared. And as an equation, the constant will be on the numerator, and so x squared is on the denominator. So y equals k over x squared. I'm just going to rearrange this so k is the subject of the equation. So k equals y times x squared. I'm going to use any pair of values here for x and y to find the value of k. So I'm just using these ones here since these are fairly easy. So x is 1 and y is 9. So when I use x is 1 and y is 9 into here, I'll get 9 times 1 squared, so k must be 9. So my equation is now y equals k over x squared, y equals 9 over x squared. Second part of the question here, we need to find the positive value of x when y equals 16. So remember, x squared is now going to be 9 over y. If I rearrange this, I'll get x squared as being 9 divided by y. So I need to find a positive value of x when y equals 16. If I substitute y as being 16 into this equation here, x squared is 9 over 16. So if I square root 9 over 16, if I square root the top, I'll get 3. If I square root the bottom, I'll get 4. So that's 3/4. Now the square root, when I square root something, the answer can be positive or negative. So my answer is 3/4, since I'm only asked for the positive value of x. And that's 4 marks for that whole question. P is inversely proportional to the square root of m. I'm told that p equals 10 when m equals 1/4. We need to work out the value of m when p equals 2 for 3 marks. So in this question here, I'm going to first of all represent this with an equation. Then I'm going to substitute these values to find the value of the constant. Then I'm going to substitute this value of p and the constant to find the value of m. So here's the steps I'm going to take. So first of all, I can say p is proportional to 1 divided by root m, because it's inversely proportional to the square root of m. Then as an equation, constant is the numerator there, and root m is the denominator. Then I'm going to substitute p equals 10 and m equals 1/4 into there. So let's rearrange k for k first. So k equals p times root m. So p is 10, m equals 1/4. So 10 times the root of 1/4. Well, the root of 1/4 is 1/2. So 10 times 1/2. So k equals 5. Now that I know the constant, I can put that into my equation. So I get p equals 5 over root m. And I know the value of p here as being 2, so I can find m. So first of all, I'll put p as being 2, so 2 equals 5 divided by root m. Then I'm just going to rearrange this, so I'm going to make root m the subject of the equation. So I can times both sides by root m and divide both sides by 2 to give me root m equals 5 over 2. So these two things just swap. So root m equals 5 over 2, so m must be the square. When I square both sides, I'll get m equals 5 over 2 all squared. 5 squared is 25, 2 squared is 4, 25 over 4. I've written it as a decimal there, but you don't have to, and my question there was worth 3 marks. In question 5, I'm told that h is inversely proportional to p, and p is directly proportional to the root of t. Given that h equals 10 and t equals 144 when p equals 6, find the formula for h in terms of t. So what I've got here is slightly different. I've got a letter being inversely proportional to another letter, and that second letter being directly proportional to a third letter. I'm told the values of all three. Okay, but I need to get h in terms of t. So these are the steps I'm going to take. I'm going to find a formula for h in terms of t and k. I'm going to substitute to find that constant, and they're going to write the formula for h in terms of t only. So first of all, I can see that h is inversely proportional to p. So I've got h as proportional to 1 over p. I also know that p is directly proportional to the root of t. P is proportional to the root of t. So I'm going to substitute this in for p. That gives me h is proportional to 1 over root t. So h is inversely proportional to the root of t. I can now write this as an equation with a constant. So my constant is on the numerator, h equals k over root t. What I'm going to do now, I'm going to substitute these values in to find that value of k. So if I rearrange this first to make k the subject, that gives me k equals h times root t. H is 10, t is 144, so 10 times root 144, that gives me 120. So k equals 120. Then I can write h now in terms of t by substituting this value of k into here. So h equals 120 over root t, and that's my 4 marks. In question 6, which is worth 5 marks, I'm told that y is inversely proportional to d squared. So when d equals 10, y equals 4. And I'm also told that d is directly proportional to x squared. When x equals 2, d equals 24. I need to find a formula which links y with x, giving my answer in its simplest form. So I'm first of all going to use this information here and use an equation to represent d in terms of y. Okay, and I'll need to find my first constant, which I've labelled as k1. Then I'm going to use this information here to find another equation linking x with d, and then I'll need to find my second constant, which I've labelled k2. And then finally I need to use both these equations to find an equation for y in terms of x and give my answer in its simplest form. So let's start that now. So first thing, y is inversely proportional to d squared. So y is proportional to 1 over d squared. So as an equation, my constant is on the numerator, y equals k1 divided by d squared. I'm told that when d equals 10, y equals 4. So to find my constant, I'm just going to rearrange this to make the constant the subject of the equation, multiply both sides by d squared, and I get the constant is y times d squared. When d equals 10, y equals 4. So 4 times 10 squared is my constant, which is 400. So 400 is my first constant. The next thing I'm going to do, I'm going to use this equation here and these values in the same way as I've done in step 1. This time I'm told that d is directly proportional to x squared, and x equals 2, d equals 24. So d is directly proportional to x squared, so d will be my constant times x squared. Now if I divide both sides by x squared, I'll get my constant is equal to d divided by x squared. Since I'm told that when x equals 2, d equals 24, I can substitute those values in. 24 divided by 4, which equals 6. So my second constant is 6. Our first constant was 400. Last thing I'm going to do, I'm going to write this equation here with my constant. So y equals 400 over d squared, which is here. I'm also going to write this equation here with my constant, d equals 6 times x squared, which I've written here. I'm going to substitute this d equals 6 squared into this equation to eliminate the d, and that would give me y in terms of x squared, which is what I need. So y equals 400 divided by 6x squared, squared again, all squared. So that'll be 400 divided by 36x to the 4. If you're not sure why that is, be sure to check my video on index laws. So y equals 400 divided by 36x to the 4. If I cancel this fraction down, simplify it by dividing the top and bottom by 4, I'll get 100 over 9x to the 4. So y equals 100 over 9x to the 4, and that is my 5 marks for that question. In question 7, I'm given 4 graphs, and I need to match each graph with the statement in the table underneath. So there's the 4 graphs, and the statements are saying y is directly proportional to x, y is inversely proportional to x, y is proportional to the square root of x, y is inversely proportional to the square root of x. So I'm going to do the easy ones first, okay? So the easy ones here, y is directly proportional to x. So an example of that would be y equals x, or y equals 2x, or y equals 3x, okay? So I need to look for essentially a linear graph, a straight line graph, okay? The only straight line graph here is graph D. Okay, it's going to be a straight line graph since the gradient of x, right, is basically a constant, and also x is, it hasn't got a power, it's just like a power of 1. So that there would be graph D, the top one there. The next I'm going to do is this third one here. Y is proportional to the square of x, the square of x. So y equals x squared. So that will be looking like a quadratic. A quadratic graph is quite simply either a U shape or an upside down U shape. So that's graph B. So as x increases, y increases even faster and faster. The gradient increases even greater than x. So that's y equals x squared. So that's graph B. Now I'm going to find this one here. This is the next easiest one. Y is inversely proportional to x. So this is a reciprocal graph. If you're not sure on reciprocal graphs, be sure to check out my video on this channel. A reciprocal graph would look like this one here. Okay, so that's graph wrong. Question 7 is worth 2 marks. I'm given 4 graphs and I'm given 4 relationships. Okay, I need to match the statements with the graphs. So I'm going to do this with the easiest ones first. All these graphs look like non-linear graphs. Okay, they've all got different gradients and the gradients are all changing apart from graph D. Graph D is a linear graph, it's a straight line graph. So look for something which could represent a linear graph. When it's directly proportional, that is when y equals a constant times x. So in other words, it could be y equals x, y equals 2x, y equals negative 5x, but it's always going to be a straight line graph. So this graph D would be the first statement here. The next easiest one here is this third one, y is proportional to the square of x. So that could be y equals x squared, y equals 2x squared, y equals negative 5x squared. So they're all going to be looking like quadratics. If you're not shown quadratics and the graphs of quadratics, be sure to check out my video on this channel. But that is going to be essentially looking like either a U curve or an upside down U curve. So that would be graph B. So the third one is graph B. The next one is the second one here, y equals 1 over x. It's inversely proportional to, so it could be y equals 2 over x, y equals 5 over x. Okay, so this is essentially a reciprocal graph. Again, I've got a video on reciprocal graphs on this channel, but a reciprocal graph would look like this, or the mirror image of this. So that's graph A. So far we've got the first one as D, the second one as A, the third one as B. That just leaves the last one as C. Y is inversely proportional to the square of x. Okay, so that's what that one would look like there. The reason why it's got a line of symmetry down the middle is because when you square something, okay, even if it's negative, it turns into a positive value. So even when I square a negative value of x, it turns into a positive value. Okay, so that is the answers there for those graphs. Be sure to look at that really carefully because you do need to know that. Okay, the whole questionnaire is worth 2 marks. The rest of the questions in the booklet are all calculator questions. Question 8 is worth 4 marks, and I need to tick the correct statement here according to these pairs of values for x and y. So is y proportional to x? Is it proportional to the square of x, or is it proportional to the cube of x? Okay, let's write each of these proportionalities as equations. So I've either got y equals kx, y equals kx squared, or y equals kx cubed. What I'm going to do, I'm just going to rearrange each equation here so that k is the subject of each equation. So for the first one, I'll get k equals y over x. So k is y divided by x if this is true. So to check if this is true, I'm going to do y divided by x for each column here and see if we get the same value of k. So is 400 divided by 5 the same as 576 divided by 6? Is 400 divided by 5, so y divided by x for these values, the same as y divided by x for these values? And it isn't, and you can check that with the calculator. So it's definitely not this middle one, this first one here. The second one I'm going to do is this one here. So I'm going to check, is y divided by x squared the same for both columns? So if I do 400 divided by 5 squared, is that the same as 576 divided by 6 squared? And it is, since I get an answer of 16 for both of these. So it's that middle one there. I can do a final check of this last one just to confirm if I have time in the exam, and it is a good idea to do that. Question 2, you need to write a formula for y in terms of x. Well, I've essentially got that. Since I found the constant as being 16, no matter which pair of values you use, I can just say y equals 16 times x squared. So there's your 4 marks for that question. Question 9, which is only 1 mark, it's a reasoning question. I'm told that d is directly proportional to the cube of n. Mary says that when n is doubled, the value of d is multiplied by 6. she's wrong and explain why. So first of all, I'm going to write this sentence here as an equation. So d is proportional to n cubed, so d must be a constant times n cubed. I'm then just going to try different values for n, right, and see if this statement that she said is correct or not. We know it's wrong anyway, we just need to explain why. I'm just going to use different values here to explain why. So I'm going to use the value of n as being 1. Then I'm just going to double that value of n, so I'll get n equals 2. I'm going to try each of these values. So when n equals 1, d equals k times 1 cubed, so d equals k. Now it doesn't matter what k is, but we know d is going to be equal to that constant. So when I double the value of n, so n equals 2, I'll get k times 2 cubed. 2 cubed is 8, so d equals 8k. So if you compare now the value of d here with the value of d here, you can see d is 8 times as great compared to when n was only 1. So it's 8 times as great. So she's wrong. So I'm writing the value of d will be 8 times as big, not 6 times as big. That's my 1 mark there for that reasoning question. Question 10 involves percentages. If you're not sure on percentages and percentage multipliers, be sure to check out my video on this channel. A pendulum of length L has a time period t. T is proportional to the root of L. The length of the pendulum is increased by 40%. Work out the percentage increase in the time period. First of all, an increase of 40% would mean the length is going to be 140%, which means that the multiplier is 1.4. I'm going to find a formula for the length in terms of t and k. I'm then going to relate the second length with the first length. And then I'm going to rearrange that equation to find the second time period compared to the first time period and write that as a percentage. So I'm told that t is proportional to the root of L. So t is proportional to root of L. As an equation, t equals k times root L. Now if I get this in terms of L, I need to divide by k on both sides, so it'll be t over k equals root L, and then square both sides, so t squared over k squared equals L. So here's my equation in terms of t and k. So L equals t squared divided by k squared. So now in terms of the second length, the time period will be different, so I'll put L2 as equal to t2 squared divided by k squared, since k doesn't change, it's a constant, and L1 is t1 divided by that same constant squared. Now I know that the length has increased by 40%, so like I said earlier, that is a multiplier of 1.4. In other words, length 2 divided by length 1 will be 1.4. So 1.4 is equal to this, and the constants can cancel each other out since they're constant and they don't change. So they cancel each other out on this fraction. So 1.4 equals t2 squared divided by t1 squared. Now to find t2 in terms of t1, I can just square root both sides of this equation to give me root 1.4, which equals t2 over t1. Now root of 1.4 is 1.1832, and so the multiplier is 1.18. So as a percentage, I can just multiply this by 100, so my percentage increase is 100, so it's 118%, which will be 18% as the increase. So 18.3% is the increase there, and that is 3 marks. Question 11, I'm told that D is inversely proportional to C. When C equals 280, D equals 25. Find the value of D when C equals 350. So I'm going to represent this information with an equation and substitute these values to find the constant, and substitute the constant to find the value of D. So here's my steps here. Representing this with an equation, I'll get D is proportional to 1 over C since it's inversely proportional. I then just substitute the values for D and C in after I've got K, the subject of the equation. So K equals CD. So K would be 7,000 since C and D are 280 and 25. So then, now I know the constant here, I can just substitute that back into this equation here. So D equals 7,000 divided by C. C is 350 now, so 7,000 divided by 350 is 20 with a calculator. 3 marks. Question 12. I'm told that at a depth of x meters, the temperature of the water in an ocean is T. At depths below 900, T is inversely proportional to x. T is given by T equals 4500 over x. Work out the difference of the temperature of water at a depth of 1200 and the temperature of the water at a depth of 2500. So that's for 3 marks. So quite simply here, it's just a matter of substituting the values in, since I'm already here given that constant. So I'm going to substitute the values of 1200 and 2500 for x, find the values of t, and just subtract to find the difference. So first x is 1200, so 4500 divided by 1200 gives me 3.75. Then x is 2500, so dividing gives me 1.8. Subtracting gives me 1.95 degrees Celsius. So that's 3 marks for that question. For the last mark in this question, I'm asked to identify which graph could show that t is inversely proportional to x. So on these graphs here, first of all, this graph here, this is a linear graph and it shows that t equals kx. This one is also a linear graph with a negative gradient, so t will be kx, but where k is negative. This one is in the shape of quadratic, so it would be typically t equals kx squared. And this graph here is an inversely proportional graph, like a reciprocal graph, so this will be t equals k over x. So that's what the graphs are showing the shape of. I need to find the graph which shows that t is inversely proportional to x. So the only one which is inversely proportional to x is this graph here, graph D. So the answer is D for that question. So that's your 4 marks for that question. In question 13, I'm told that y is inversely proportional to the square of x. I'm given the values of y and x, so I can find the constant of proportionality there, and then I can substitute that along with this value of y to find the value of x. So here's the steps I'm going to take. So I know that y is proportional to the inverse of the square of x. So y equals the constant divided by x squared. If I rearrange that, I can get the constant equals yx squared. I'm going to substitute in the values of y equals 8 and x equals 2.5. That gives me the constant, which is then 50 with the calculator. Now I can substitute this value of 50 and the value of y as being 8/9 into this equation here, which gives me 8/9 is 50 over x squared. Now if I just rearrange this so that x squared is the subject, so multiply by x squared on both sides and divide by 8/9 on both sides, I'll get x squared is 50 divided by 8/9. And square rooting, I'll get plus or minus root 50 over 8/9. It's plus or minus since when I square root I can have a negative answer as well. Now they're only asking for the negative value of x, so that is negative 7.5 with a calculator. And that question there was 3. Question 14 tells me that t is inversely proportional to the cube of u. When u equals 5, t equals 0.0096. That allows me then to evaluate the constant of proportionality. And I can then substitute that to find the value of u given the value of t. So here's the steps I'm going to take. T is proportional to 1 over u cubed. So that t equals the constant divided by u cubed. Rearranging this to make the constant the subject, I'll get tu cubed equals the constant. T is 0.0096 and u is 5. Evaluating that with a calculator, I'll get the constant as being equal to 1.2. So now I can substitute that value of k and the given value of t as 0.15 into this equation, rearrange it to make u cubed the subject, and then evaluate that, and that gives me a value of 2. That question was 3 marks. Question 15, I'm told that y is inversely proportional to x cubed. I'm given the values of y when x is equal to a. Show that y equals 5.5 when x equals 2a. So in this question, I'm going to represent this with an equation. I'm going to substitute this to find k in terms of a, and then I can substitute k to find y given the value of x. So here's step 1. Y is proportional to the inverse of x cubed. So y equals the constant divided by x cubed. So then substitute y is 44 and x equals a. I get 44 times a cubed as constant. Now I can substitute these values here to get the value of y. So y is 44a cubed, from this 44a cubed divided by x cubed, where x is now 2a, so 44a cubed divided by 2a all cubed, which gives me 44a cubed over 8a cubed, and then a cubes cancel, so 44 divided by 8 is 5.5, and that there was 3 marks. In question 16, I'll have to match 4 graphs with the corresponding descriptions of their functions. I've included this in the booklet since it does involve proportionality. It also involves trig graphs and exponential graphs and reciprocal graphs, so if you're not sure on what those may look like, be sure to check out my videos on this channel. So this graph A is actually a sine graph, so that's a graph of sin x. Okay, so I've labelled it up there. This graph B is known as a reciprocal graph, so this can also be represented using this equation here. So the function is known as, this function is inversely proportional to x. Graph C, this is known as a root curve, so f of x equals root x. And graph D, this is known as an exponential graph, so f of x is 2, or any base really, with x as the index or the power. So knowing that, we can start to then match up these graphs. This is the answer we should get. This first graph here, sin x, well that's the trig function, that's the easy one. This graph B here, that was the inversely proportional graph. This graph here, that was the graph which is direct proportional to root x, leaving this one here which is the exponential function. That question there was worth 2 marks. Be sure to check out my other video files on trig graphs, reciprocal graphs and exponential graphs on this channel. Thanks for watching.